So our notes today, it's called function notation. So we learned about what a function is, and then we went more specific last lesson and we talked about what a linear function is. Function notation is a fancy way to write a function. We've seen our functions all have a y and an x in them, right? So function notation is going to be using a fancy way of writing it. Now, you should be familiar with y equals mx plus b, right? What is y equals mx plus b? Slope-intercept form, correct? So slope-intercept form has a y and an x in it, and it also has an m and a b, right? We're going to talk more about this next week, but my first question is, what does m stand for in this equation? Slope, thank you. What does the b stand for? What kind of intercept? The y-intercept, right? Again, we're going to talk more in depth about this next week. However, do you see where it says y and x? Right? All right, so where it says y, instead of y, we could replace that y with something called f of x. I know that sounds weird, but if you look right here, do you see where it says f parentheses x?
Does that mean function?
It does mean function. That is correct. So f of x means that this is a function of x, which is kind of weird and confusing. All I need you to know is that f of x is a fancy way of saying y. If you think about this, some kids will ask, why are we having to replace y with f of x? The reason we replace y with f of x, think about your parents. If you have siblings, did your parents name you and your siblings the exact same name? No. Probably not, right? Even if they really like your name, why did they decide to name you and your siblings different names? To not confuse you guys, right? So if I gave you 3 different linear functions, or any functions, but we're going to talk about linear functions. Let's say I said y equals 3x plus 1, and y equals negative 2x minus 5, or y equals 1/5 x plus 8. I'm making these up. But if I wanted to talk about one of these functions in particular, they all start with y. But if instead we replace those y's with different beginnings, like f of x, and just like f of x, you could use other ones like g of x, or even h of x. Those are just new names for each one. So if I told you that I wanted you to graph g of x, would you know which one I was talking about now? Yeah. If I didn't put those, if I kept it as y, would you know which one I was talking about? No. So it's just like giving new names to different functions, so that way you could distinguish between them. Okay?
Is only the letter f the function or any other function?
F is standing for function, but if there's more than one function, more than two, then more than one, they sometimes will use a different letter, so that way you could tell the difference. It's still a function, absolutely.
What if it's only 2? It's still f then?
What do you mean only 2?
Like, you said if it's more than 2, so if there's 2,
More than 2 functions? Then what?
it's different letters.
Yes, usually they'll use a different letters. They could say g of x, h of x, m of x, okay? So, everybody, hold on one second. Everybody say this with me. It's not fx, it's f of x. If you see that, or g of x, or anything like that, you say f of x. Repeat that with me. F of x. Not fx, f of x, okay? So, the first thing we're going to talk about is evaluating a function. So you could see this function, f of x, is equal to negative 4x plus 7. Didn't we say f of x is a fancy way of saying y? So isn't that the same thing as saying y is equal to negative 4x plus 7? Right? Now, when it says the word evaluate, and they give you different numbers for x, that means you're going to plug those numbers in for x and solve and get out a different number for y. So for instance, it says evaluate f of x equals negative 4x plus 7 when x equals 2 and when x equals negative 2. So what that means is we're going to go to that equation, and where it says x, we're going to plug in a 2 and do the math, and then we'll go to x and we'll plug in a negative 2 and do the math. So do you see here they took this function where it says f of x, and do you see where they put a 2 where it says x? What that is saying is f of 2, which means you're plugging a 2 in. So it's saying I'm plugging in a 2, and then they actually plug in the 2. So where it says x, you're going to plug in a 2. What's happening to the -4 and the x right now? It's being multiplied. So I'm going to say -4 times, I'm plugging in what for x right now? 2, right? Plus 7. So -4 times 2 is -8. And what is -8 plus 7?
Okay, so whatever is next to the f in the parentheses, we just...
That's what you're plugging in, yes. So what you would say is f of 2 is equal to -1. That means this function equals -1 when you plug in a 2. So f of 2 is equal to -1. That means when you plug in a 2, it equals -1.
Where you get the 2 from?
They said it in the question. They said plug in a negative when x is 2. And then what else did they say? When x is -2. So over here I'm going to do the same thing, except this time I'm not doing f of 2. I'm doing f of -2. So I'm plugging in a -2 where it says x. So -4 times -2 is +8. What's +8 plus 7? It's not 18.
My bad.
15. So f of -2 is equal to 15. That means when you plug in a -2, you get 15, right? So f of 2 is -1 and f of -2 is +15. Does that make sense?
Yes.
Okay. So if we look at this example, now we said f of x. In this example, they're not saying f of x. They're saying f of what?
0.
No, right here. F of t. Because they're talking about temperature. So that's why they didn't use x here. They're using a t. That's fine. It's still a fancy way of saying y. So basically, they're plugging in numbers for t. It doesn't say T stands for temperature. Technically, it says T stands for the hours after 6 a.m. If you think about it, if you were to wake up at 6 a.m., isn't it going to be colder than it will be later on in the day?
Yeah.
It's usually colder in the morning than it is in the afternoon, right? So this is saying that T is going to represent the number of hours after 6 a.m. So if this first example says F of 0 equals 58, and this part right here represents the amount of hours after 6 a.m. So what time is it if it says F of 0?
0.
How many hours has passed?
6.
0 hours, which means it's at 6 a.m., right? And what's the temperature it's saying is at that time then?
58.
So that means F of 0 equals 58 in this situation would mean
0, 6.
at 6 a.m., it's 58 degrees out, right? Do you agree? Yes. Part B, F of 6 equals 75. What is that going to mean?
It's 6 hours after 6.
6 hours after 6 a.m., which is what time?
12.
Which is noon, right?
Yes.
So at noon, what time is it? Or, I mean, what temperature is it?
75.
And then lastly, F of 3 means, what time is it if it says F of 3? 6 p.m., right? No, 6 a.m., 3 means 3, F of 3 means 3 hours later, so 9 a.m., right? So at 9 a.m., it's 63 degrees. Does that make sense? If there's a scenario and they're telling you what the variable represents, in this case it's the number of hours after 6 a.m., then that's what that would mean. Okay? All right. Now we get to graphing, which is very important. We're going to talk about graphing linear functions next week as well, and I'm going to give you an easier, better way. But for today, if I ask you to graph this function, that's a linear function, right?
Yeah.
It's a linear function because it does not break any of the rules. X is not to the second or third or fourth or any power. It's to the first power. X and Y are not in the denominators. X is not in a radical. There's all the requirements are being met. And we know f of x is a fancy way of saying y. When we say x and y and we're talking about an input table, what part of the table is X? Is that the input or the output?
Output. Input.
Input. So this is my input, right?
When it's just fx, it means y.
F of X.
That it means y, right?
Yes. So the X is my input. My F of X, which is the Y, is the output, right? Now, if they don't provide a table for you, you should make a table. Okay? Now, what did we say the X was when we're talking about independent and dependent variables? The input is what? Independent or dependent? Independent. You could put whatever you want in, but the output is dependent on what you plug in, right? We're going to graph this function by replacing X like we did a minute ago. Remember when we evaluated and we said F of 2 and we would plug in a 2 for X, and F of negative 2 and we'd plug in a negative 2 for X, right? So what we're going to do is we're going to take this equation, because if you want to graph something, don't you need ordered pairs?
Yeah.
Don't we have to create ordered pairs right now? The way we're going to do that is we're going to plug numbers in for X, solve it, and get a number out for Y, and that will create an ordered pair. We'll do that a handful of times. Now, I said you could plug anything you want in, but remember, you're going to have to do the math and also graph it. Do you guys want to plug in these really big numbers where you have to work with these big numbers and then graph big numbers? Probably not, right? I put a little note off to the side and said, yeah, you could put any number in because it's the input. However, I would highly suggest that you use the numbers -2, -1, 0, +1, and +2. You want a couple negative numbers and a couple positive numbers. However, these are easy numbers to work with. They're small, and you have a 0 in there, which is easy to work with as well. So what I'm going to do now is I'm going to take this equation. It says F of X is equal to 2x plus 5, right? But where it says X, what am I replacing X with? First, I'm going to plug in a -2, right?
Times -2.
Yep, because whatever F and X are, they're multiplied together, right? So let me actually erase this so I have more room. It was 2 times whatever X is plus 5, right? All right, so first we're going to plug in a -2. Well, 2 times -2 is -4. What's -4 plus 5? +1. So the Y, the output, is 1, which is F of X is a fancy way of saying it. Now I'm going to go back, and instead of a -2, I'm going to plug in a -1. -2 times 1 is -2, and -2 plus 5 is 3. What am I plugging in next?
5.
No.
0.
0, right? 2 times 0 is 0, and 0 plus 5 is 5. Oh, you were saying the final answer. All right, now I'm plugging in a 1. 2 times 1 is 2. 2 plus 5 is 7. And then lastly, I plug in a 2. I don't know why it's not letting me erase all of a sudden. So I plug in a 2. 2 times 2 is 4, and 4 plus 5 is 9. Yes. All right, so these are all ordered pairs now. So this one right here, -2 and 1, the ordered pair would be -2, comma, +1.
Where'd you get the output from?
We did all the math to get the outputs.
No, I know, but like,
Okay, so it goes x-axis first and then y-axis.
Yes, x-axis, then y-axis. Hold on one second. I'll answer your question in 1 second. All right, the next ordered pair is x is -1, y is +3. The next one is 0, 5, 1, 7, and I'm running out of room, but also 2, 9. So now we have to graph all these. So I'm going to graph each one. So yes, the x-axis is the one that is here, and that comes first in each ordered pair. So -2, +1 means go over -2 on the x-axis, up 1 on the y-axis, so right there. So -2, 1, right? The next ordered pair is negative 1 comma 3, which is right here. 0 comma 5, 1 comma 7, and 2 comma 9. And the last thing I'm going to do is I'm going to connect those points, because didn't we pick these numbers, negative 2, negative 1, 0, 1, and 2? All right, so we picked these numbers in the input, right? We chose to plug in a negative 2, a negative 1, a 0, a 1, and a 2. If I wanted to, could I have plugged in 1/2? Sure, I could have. I wouldn't want to because it would be more work to plug in a fraction, but I could have. Could I have plugged in 1.3? Absolutely, I could have. So my point is, this is not discrete data, this is continuous, right? It's all the fractions and decimals in between. So what we're going to do is we're going to connect these points with the line, because it's not just those ordered pairs, it's all the ordered pairs in between too that we would have gotten if we plugged in all those other decimals and stuff. Now, oh, this is not the type that makes it a straight line. If I wanted to, could I have plugged in a 3? Can I have plugged in a 4? Can I have plugged in a 100? Can I have plugged in a negative 10? Yes, I could have plugged in any of those. So I'm going to put arrows on the end of both of these lines to show that it would keep going, because I could have plugged in all the numbers, all the positive bigger numbers and all the negative bigger numbers. But if you plug in any number to x and you follow this function, f of x equals 2x plus 5, your output, the y value, will be an ordered pair that's somewhere on this line. Okay? Put that away. Away. Thank you. All right. So that is pretty much the lesson. So now you have your turn